Hey everyone, welcome back to my channel. Hope you guys had a good weekend. So today we are going to be jumping into the 11th problem of the LeetCode 75 study plan series. This problem is part of the two-pointers category, and it's called is subsequence, and it's going to be ranked easy. So for those of you who don't know what two-pointers is a type of approach used for, I don't know, I guess you could say it's a type of algorithm used to solve specific problems. It occurs pretty frequently in LeetCode, and I would say it's kind of a beginner-friendly concept to master. So I hope that this problem is going to be useful for you to be able to implement that approach on your own. So let's go ahead and dive right into it. So for the instructions, it's given two strings of S and T. Return true if S is a subsequence of T or false otherwise. A subsequence of a string is a new string that is formed from the original string by deleting some, can be none, of the characters without disturbing the relative positions of the remaining characters. So for example, ACE is a subsequence of ABCDE, while AEC is not. So basically what they're saying is that it doesn't have to be consecutive characters in a row in order for it to be a matching subsequence. So it just has to contain all, basically string T has to contain all of the characters that string S contains. So if we look at our constraints, S can be equal to or greater than 0 and equal to or less than 100, and then T can be quite large, and it just has to be greater than or equal to 0. So the first thing that we want to do to kind of protect our edge case for when S is a size 0 is we want to implement a condition, an if statement, right, that checks if S length is equal to 0, then we return true. Because if S is 0, then that means it's definitely, T definitely contains it because it's empty. So that's pretty, that's pretty self-explanatory. So what we need to do is, since we're doing a two pointers approach, we need to create two pointers. So we can call one S index, and these are going to be integers, and then we can call the other T index. And I found that the easiest way to do this, in my opinion, is to implement a while loop. So basically what we want to do, the idea is that we iterate through the characters of the T string, and then if one of those characters equals a character in the S string, then we want to increase the S index up, and then we want to go iterate through the loop while until S is equal to the size, the S index is equal to the size of the S string. So that means that we have all the characters. That means that the T string contains all the S characters, and therefore it's true, and we can return true. Otherwise, we return false. So let's set up the while loop. So while T index is less than T dot length, okay, we're going to check if T char at T index is equal to S char at S index. Okay, and then if it is, then we increase the S index. Then we want to set up another if statement. If S index is equal to S dot length, means that we have all of the characters, and we return true because that means it's a subsequence. And then for each iteration, we don't want to forget to add 1 to T index. We can do that with a plus plus. And then if it still doesn't find the complete subsequence in the while loop, after it breaks out, we want to return false because that means that we don't have a subsequence. So this should work. Let's go ahead and run this. Okay, so it's accepted. Works with the two test cases. So now let's try and submit this, make sure it completely works with all the test cases. So yeah, as you can see, it has a runtime of 2 milliseconds, beats 58.69% of the solutions, about the same with the space complexity. So moving on to that, for the time complexity, it's big O of n because it just iterates through the T parameter ones. And then for the space complexity, it's just going to be big O of 1 because we're not allocating any new data structures that scale with the size of the input. So we're just using integers, which can be just that don't count towards the space complexity, basically. So that's it for today's problem. If you guys have any questions about how I solve this problem, please go ahead and leave it in the comment section. If you have any questions in general, please feel free to leave those as well. And then if you have any suggestions, I'm super open to hearing any suggestions for video ideas or just whatever related to computer science in general that you want to suggest. I'm all ears, and I'll try to respond to all of your guys' comments. But until then, I will see y'all in the next video. Don't forget to subscribe and like.